Okay, we're on R12 review, and this topic covers applications of derivatives. Lots of things here. First, average rate of change, f of a plus h minus f of a is h over h. And we usually say that's f of b minus f of a over b minus a, but sometimes it's given to you in this format. So that's the average rate of change. And then instantaneous rate of change is f prime of a, which is the limit of this average rate of change. So the limit as h goes to infinity. So, as h goes to 0, gets closer and closer to 0. F of a plus h minus f of a over h. Okay, and then remember the tangent to a curve. Okay, you just know that the derivative is 0, so it would be at a place where you would have a derivative of 0, and that means the derivative is 0 at these places when it's tangent to a curve. And if it's vertical, like this one, when it's vertical, then it would be doesn't exist. So don't forget that, and you just use the y minus y1 equals m, which is f prime of x, and then x minus x1. Normal, let's try to remember the normal is the negative reciprocal of f prime of x. Okay, so you would use the slope and you would use the negative reciprocal of the slope. Optimization is a big topic often, and we'll do a lot of these today. Optimization usually uses implicit differentiation, but it just means like you're finding the max or min of a function that's not a graph. It's usually like a word problem. And then lastly, tangent line approximation. And remember that you can use f of a plus f prime of a times x minus a. Delta x, remember this is delta x. And remember this is a plus because a lot of people try to put a minus there when they do it. Okay, so let's look at problem 1 on your notes. We have g is equal to 400 times 1 minus, 15 minus t squared. It's in a cistern, it's a tank, and every t minutes after an outlet pipe is open, that's how much water's in there. Find the average rate of drainage during the first 5 minutes. So average, because they use a average rate, okay, that means we're going to use average rate of change. So we're going to say over the first 5 minutes, it would be f of 5 minus f of 0 over 5. So that would be 400 times 15 minus 5 squared minus 400 times 15 squared over 5. And so that is 4,000. This would be 100, right? So that would be 40,000 minus 15 is 225, so 400 times 225 over 5. So let's say 225 times 400 do 28 and 10 8 9 90,000. So we have 40,000 minus 90,000 over 5. And so that would be negative 50,000 over 5. which is negative 10,000 gallons per minute. Okay, so find the average rate, and then it wants the rate at which the water is running at the end of 5 minutes. So you would take G, this is for part A, and for part B, that doesn't really say A and B, but it's the second part of the question, it's G prime of 5. And so G prime of 5 would be 800 times 15 minus T, and then multiply that by negative 1, and you get 80 times, and then putting in 5 in, right, you get times 10, 800 times 10, times a negative 1, so you get negative 8,000 gallons per minute. Okay, so that was an average rate. Let's look at number 2. Find the equation of the tangent to the curve of f of x is equal to x cubed minus 3x squared at 1 comma 2, negative 2. And so you just want f prime of x is 3x squared minus 6x, and then you substitute in 1, negative 2. You would just put in, to find the slope, you just put in the 1. So you get m equals, I'm going to say m because now that's what I'm doing, 3 minus 6, which equals negative 3. So then, put in an equation, y minus y1. So y plus 2 equals negative 3, x minus 1. And just leave it like that. You don't want to simplify, especially on the AP exam.